Today, solving systems of inequalities, section 3.3. Again, if you look at number 2 on the warm-up, if you can do that problem, you can do what we're doing today. We are just going to be solving multiple inequalities, really. Okay, so graphing inequalities, we've done that already. Really what it's going to be like is if you take 2 problems from what we did last chapter and put them into one, that's today. Section 3.3 here. So if you look at the examples here, we're going to be given problems like this. Kind of look right here. We're going to graph 2 inequalities. The first one says y is less than or equal to x plus 2. You know, this is what you would have done last time. So last chapter we did problems like these. You know, you graph it, look at your y-intercept, look at your slope, you graph it, and you shade like you would. That would have been last chapter. This chapter now, we're going to do that, the first one, just like we did. So we graph that, and we shade. And now we're just going to take a second one is all it is. So now you take the second one, x is greater than 1. Bring in your dotted line, and you shade. And we are going to look for the overlapping region. So our answer is going to be now this overlapping region right here where they both cover. So again, that's all it is today. Is you're taking 2 problems essentially and putting them into one and finding out where they overlap. So let's look at number 1. I want to solve the system of inequalities. Bailey, what color would you like to see today? I have multiple colors up here. We'll make it fun. What color? I can't hear the color.
No, like what colors do you...
I got all these colors right here.
Purple.
You want purple, okay. So we have a purple one here. Y is less than x plus 1. What is the y-intercept in that graph, Jack? 1. So I'm going to start at a positive 1. What's the slope in that one then, Garrett? So up 1 over 1, up 1 over 1, up 1 over 1, or down 1, left 1. Solid or dash line, Shane?
Dash.
Dash. And do I shade above or below, Mark?
Below.
Below. So there's our first one right there. There's our purple line. Reagan, what color would you like to see?
Yellow.
Yellow. There we go. There's yellow line. So if y is greater than negative x minus 1. Sean, what's my y-intercept? What's my slope here, Jarrett?
That'd be -1.
So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, or up 1, left 1. Solid or dash line, Phil? Do I shade above or below Colin? Above. So I shade there, and now I'm going to look, where do they overlap? Well, they actually overlap in this area right over here to the right. So that is where our answer is today, where they are satisfies both systems. Again, is that just the same as pretty much what we did last week, taking 2 problems covered in one? Yeah, that's really what it is today. All right, number 2. Solve the system of inequalities. I love these graphs. These are my favorite ones to do because we always kind of confuse them some yet. Let's see here. Colin, what color would you like to see? Blue. I'll go with a different blue. There you go. So y is greater than 1. What type of line is that going to get me, John?
Vertical.
Horizontal line. Y equals always gets us a horizontal line. So I go through 1, so 1 on my y-axis. And I'm going to shade above it because it's greater than. All right. Sophie, what color would you like to see? Dark blue. I got a nice dark blue here. So I have that one right there. X is greater than 1. What type of line does x is greater than 1 get me, Andy? No. Y equals gets me horizontal. X equals gets me a vertical line. So now I go through right there. I have my vertical line. So there's my vertical line. Now I want to shade greater than that. Where would greater than that be, Ethan? To the left, right?
Right.
To the right is where it's greater than. So I shade all that area. Now I'm looking for where it overlaps. It actually overlaps in this top right area right here. So that would be our answer that we're looking at today. If you have multiple colors on your iPad, definitely use multiple colors. If you don't, you can go, shade vertical and then shade horizontal, just like I did there. And then you can see kind of where you overlap a little bit better. Or if you really want to just darken it in a lot, and then you can see your area, just like that. All right, try number 3 here. Take a couple seconds, try number 3. Same idea. Graph each inequality. Look for the boundaries. All right, if you look there, there's where your graph's region should be. It's kind of the top left. Now, if you look, they're both positive slopes. So you do recognize the positive slopes. So it's going to be way up to the left. Everything going on and on and on in all of those directions would fit these inequalities. All right, next thing we're going to talk about here is what happens if we have multiple, more than 2 now, inequalities to graph. Well, if I have multiple inequalities like this here, I get multiple boundary lines, and then I can actually have a figure. So if you look over here, my boundary lines make a geometric figure, and we're going to have problems that's going to ask us what the geometric figure is. Well, looking at that, I have parallel lines because they are both vertical lines. Vertical lines are parallel. The other 2 lines are not, so that would be just like our warm-up review. That would be a trapezoid right there. So these problems are no tougher, really. The only difference is you're going to have more than 2 to graph. So you might have 3, 4, maybe even 5 of them to graph, and to kind of say what type of geometric shape it makes. So let's try number 4 here. I have 3 of them to graph. So I'm going to start here with y is less than or equal to 2x minus 2. So I'm going to start with my y-intercept. What's my y-intercept, Jack?
-2.
-2. Up 2 over 1. Up 2 over 1. And that would be a solid line through that now. Now we have the solid line because it's less than or equal to. And it's less than, so I'm going to shade below. So there's my red line. Now when you get multiple ones like this, you might want to make sure you kind of shade lightly, just so you can see where they're overlapping. It can get tough. Y is greater than negative x. What's the y-intercept there, Sean? Y is greater than negative x. What's my y-intercept? 0, yeah, because it's like saying you can always add the plus 0. So we're right there at 0. Now negative slope means my graph's going to go down. So down 1 over 1, down 1 over 1. And I have a dashed line right through there where I would shade above. And then my last line, x is less than 4. What type of line does x equals get me, Garrett? Gets me a vertical or horizontal? Vertical line right through 4. And now I'm looking for less than, so that's all this area over here. So now I'm kind of looking, where do my 3 areas or my 3 lines cover up? Well, it's this area right in here. And then I'm going to say, what type of geometric figure is that? Well, that actually makes a what, John? A triangle. Now, you can be more precise. Does anybody know what type of specific triangle that makes? I believe it's actually just slightly over an obtuse triangle, actually. Barely, not by much, but it is barely over an obtuse triangle from what I believe. I'm gonna go on to that, I think. But yeah, that'd be a triangle there. And again, just kind of shade that in darker if you can to recognize it. All right, try number 5 on your own. Same idea here. Your actual triangles may be very, very small to see. But take a couple seconds to try this one. All right, if you check yourself there, we're looking at that small little bitty triangle that's right there in the middle. Again, might be tough to see, but that's where they do overlap. And that would be a triangle again. All right? Any questions today? really, again, you know how to do all these different parts. The only difference today is you're going to have to put them all into one graph, really. Okay? Here is your assignment.